All right, welcome to our next video in our series on programming in Snap. This video assumes very little understanding about what Snap is. It's great for beginners. And the idea today is we're going to go category by category, talking about the different blocks that we can use. And today I think the first category that's very important is the motion category. It's dark blue, and it helps get your sprites to move around the screen. There's a couple of concepts we're going to need to cover in this video to help it make sense. We need to talk about the coordinate grid of the stage. That's that area you see in the top right where the sprites will move around and do their thing. The other thing that we got to talk about is we want to know the coordinate grid. We want to talk about the dimensions of the stage. Dimensions of the stage. Meaning, where is 0, 0? Where are what's the coordinates of the top edge, the bottom edge, right and left? Lastly, we're going to talk about how Sprite handles direction. And you'll see me borrow blocks from a few other categories. I like to use pen blocks to draw lines here. We like to use, sometimes control blocks can help a particular block reoccur in a loop, or you might see a few different triggers here. But for right now, we're going to talk about what all the move blocks do and how can you take advantage of all these awesome dark blue blocks. So number one, let's throw some coordinates up on the grid. And I think the easiest way to paint the coordinates is to make a script that does it. So I'm going to go to Control. I'm going to decide how about when the C key is pressed, we're going to paint some coordinates to the grid. So to get the coordinates, I'm going to tell it to go to the topmost point. That's going to be right up here, top center. And that coordinate is at 0, 180. And then we're going to go ahead and I'm going to have it pick the pen up just in case I left it down from the last time I executed. I'm going to go and pick it up. Then we're going to say pen down. And then I'm going to go ahead and go to the bottom center part of the stage, which is at negative 180. So when I press C, whoop, it paints me a line just like that, which is great. Now I want to do, that's basically your y-axis, right? If you imagine your algebra class y up high, the y-axis helps us measure how far up and down we go, just like that vertical line. So now we need an x-axis, which goes from, we'll do it from left to right. So I'm going to pick the pen up so I don't accidentally trace a line right here. We're going to go to the left center edge, which is at negative 240, positive, negative 240, y equals 0. Then we'll go ahead and put the pen down. And then we're going to take it all the way across the screen. We're going to say go to positive 240. And then just to be responsible, we'll go ahead and pick that pen up. And I click C. Whoops, C. Oh, I said negative 240 twice. That's fine. Positive 240. Boop. There it is. We can see it drives the whole way across. You might be interested to know, when it was just off the left edge, we couldn't see it at all. But as it moved, you can just barely make out the tip of the sprite right there. But it moves to the other edge, we see the sprites fully remained on the screen. And that's because the center of the default turtle sprite is at the tip of the arrow. Whoops. So if I go look at this turtle, it's going to be, I wonder if we can't actually do it. Normally you can look at a costume and see where it is centered, and that'll tell you where the pen traces from, the point that it turns about. But in this case, we can't see it. I'll just have to tell you that the center is right here at the tip of the turtle. So what are some of these blocks that we've already used? Well, I used this when C key pressed. This is called a hat block. This is what starts a script. And then I did a lot of picking the pen up, going to a location, putting it down, drawing a line, picking it up, going to a new location. So you can see this coordinate grid right here. And this gives you an idea of the dimensions of the stage. So it is 360 total steps high. That means that if the middle is 0, 0, that this point is positive 180, y is positive 180, y is negative 180 right here. It's a little wider than it is tall, so x is negative 240 on the left, x is positive 240 on the right. So now that we've got an idea of what the stage looks like a little bit, let me show you, a good description of like a slanted line would be the y equals x line. Like what's the line when the coordinates are the same? So I can show you, we'll pick the pen up, we'll go to one more location. I'm going to take it to negative 180, positive 180. And then I'm going to show you a new one. This is called glide. Oh, here, I guess we got to put the pen down first. Pen down. Pen down. And we're going to glide to the opposite side, 180, 180. Now, you might think to yourself, oh, 180, 180. That must mean that it is going to be the corners. Well, be careful. When I press C to paint that coordinate grid, we can see that it is not a square region. It is a rectangular region. The point negative 180, negative 180 is here. The point positive 180, positive 180 is here. All right, so we've got a good idea of what all of the dimensions are of the stage and how it represents a coordinate grid. Let's talk about movement. So I'm going to go ahead and pick the pen up just to make sure we don't draw anything. There's a few different strategies you can do when it comes to movement. You can tell your sprite to jump to a particular location on the screen, and GoTo is a great example of that. GoTo 0, 0. If ever I lose my sprite, if my sprite goes flying off the edge of the map, I'll just drag GoTo 0, 0 out of my stage, click on it, poof, and it comes right back to the middle. I think if I'm not mistaken, you can even click on the block in the blocks box over here on the left, and it'll still execute the command for you. So some movement just says go to a particular location on the stage. Examples are go to 0, 0, go to, and you can specify the name of another sprite, or the random position, or the mouse pointer, or the center of the stage. Or sometimes we want to glide. And the question gets asked, what's the difference between go to 0, 0 and glide? The difference is glide takes a minute to get there, whereas go to 0, 0 is instantaneous. Now, glide looks really nice, but one thing that new programmers will stumble on sometimes is while a sprite is gliding, it's often hard to get it to perform another task. If you need to move it, if it needs to detect collision with another sprite, if you needed to do anything else, it really can't. It's kind of stuck while it's gliding. So that's why I actually kind of recommend against gliding if you can help it. If you really want to use it, that's okay. A couple other things that can jump you around various places, you can use set X or set Y. Now, these will leave the other coordinate alone and set the coordinate that you've asked for. So if I set X to, say, 100, it'll move me to the X equals 100 location on the map. Wherever I am, X will go to 100. It doesn't care what Y is, X goes to that 100 right here. Let's say I want to set Y to, I don't know, how about 0? Boop, it comes back to that nice middle line. It could be up here, boop, comes back to the middle. So all 5 of these blocks do a good job of saying, we don't really care where you are on the map. We're going to have you jump to a particular location. I guess set X and set Y will leave the other coordinate alone, so it does matter a little bit what that position is. So that's those 5 right there. The next one is sometimes you can just ask it to move from the position it's in currently. So examples of, here, I'll go ahead and snap all these together. These can jump your sprite. The ones that move you from a relative position are move, change, and change. Change X by and change Y by. So the idea behind these are they move you in little bitty increments. And remember, if the width of the stage is we go from negative 240 to positive 240, well then I could get, let's say I were to change my X to negative 240, and then I were go to that location. It would take me 48 clicks of the mouse. Did I go? Oh, change X by negative 240. Oops, I meant to make that set X by negative 240. We're way off the edge of the map right here. Let's see here. There we go. Oh, somebody taught me, I think there's a tool for splitting extract. Yes, you can grab an individual block using this extract command. Oh, that's so handy. I can't even tell you. All right, so I think we should be on the edge right here. So if I go to start moving 10, it would take me 48 clicks of the mouse to get from one side to the other because it's 480 steps and I'm going 10 steps at a time. Okay, So move cares about where you are, and it also cares about direction. We haven't changed direction at all yet at this point, but we will in a moment. Change X by also cares about where you are, but it does not care about direction. Oh, that's too much. So if I say change X by 10, wherever you are, we're going to move in the X positive direction. That would be to the right. So if I click this a bunch, it goes to the right. If I say change Y by 10, that means that we're going to go in the Y positive direction. So we're going to go vertically. And I can obviously use negative numbers if I want to change this. If I want Y to come down, I'll use a negative. If I want it to travel to the left, we'll say X is negative. And if I want it to move backwards on move, I can do that as well. So you've got some blocks jump you around the stage. Some blocks will move you relative to your current position. And the last thing we really need to talk about is point in direction. So we've got point, we've got turn, let's see how that's clockwise and counterclockwise. Those are some options. There's a few more handy things we'll talk about after this, then we'll be done with our video. So point in direction is where I want to start because it explains the number system that Snap uses for direction. If you wanted to go up, that is considered 0 degrees. Straight up is 0. To the right is 90 degrees. Down is 180. Left is 270. And then as we get all the way back to straight up and down, 345, boop, we're back to 0 again. So you can just pick a direction and set it. You know what? I want this thing to go left. When I click on this, the turtle, my little sprite, turns around, and now all of my movements, here I'll change that to positive, now move goes this direction. But if I change it so that now I'm pointing to the right, now all my movements go to the right. So we can ask it to pick a specific direction. It'll ignore where we were before and aim at one particular direction. We can also ask our sprites to point to particular objects. They could point to another sprite. They could point to the mouse pointer. They could point in a random position. You can click this random position, and it'll go into a bunch of random different directions. So those are both options. And then the other one is, here I'll reset this back to, the default's usually 90 pointed to the right. You can ask your sprite to turn. And so you could say, all right, if I click clockwise, boop, it tips a little bit to the right, and now when I move, I'm aiming down. If I pick clockwise, that puts me back to level, one click, another click, now I'm aimed upward, and now we can see the sprite climbs. We can ask the sprite to spin a whole bunch in place if we feel like it. And what we're going to see happen later as we develop our skills is we'll attach some keys to this turning, like maybe the good old-fashioned WASD, and you'll get A will turn you left and D will turn you right, and you can really make it look like a spaceship flying through the game of Asteroids, right, the vintage game. So I think we've covered most all of the blue blocks here. There's a couple of cool nifty ones that we should address, some real time savers. First, I want to talk about these checkboxes down here, these checkboxes. If ever you've got a question about the position or orientation of your sprite, you can check one of these boxes and it'll tell you down to incredible precision where it is. The X position's at 133.5. The Y position's at 12.5. I see as I move this closer to the origin, both of those numbers get smaller because they're getting closer to 0, 0. If I move it down here into the third quadrant, right, where both X and Y are negative, we see the numbers got bigger as we moved further from the origin, and they got negative. So you can figure out their direction. You can also drag these round-looking blocks onto the code. It's hard to explain the purpose of these until we are a little bit later in our Snap development, but I'll let you know these are an example of something called a reporter, and it's their job to be plugged in to see how some of these slots in these blocks are rounded. Well, they could get plugged in to those locations to provide information. If we click on them, we can see they're holding the X position of the sprite and the Y position of the sprite, and there's a third one that allows you to check direction, which is currently 0. So I can turn all three of these pieces of information on, usually to try and figure out where my sprite is or what I want it to do. Or if I know, I need it to appear here, I can turn on my coordinates and say, all right, that's at 131 negative 66. And now, to get it back to that point later, I can just remember it's a go to 131 and negative 66. So let's say the sprite's moved around, it's attacked some enemies and got some gold, and it needs to teleport back to that specific spot. Boop, I teleport it right back there, and it's good to go. So these are the position and direction reporters. That's these blocks down here. The last blue block we haven't talked about. What an important blue block. You're going to use it a lot. It's called if on edge bounce. And it's built to solve a particular problem. And the problem is sometimes when we combine here, let's go ahead and point towards random direction. Oh, yep, that looks good. Sometimes we're going to ask our sprite to move a lot. And to repeat an action, you can use a loop. I'm going to use a forever loop for this demo. And what happens is you can say, you know what, forever move. Just keep on moving. And I'm going to set this on 3 so it isn't quite so fast. Well, when I turn this loop on, watch what happens. It takes off and it leaves the screen. And because I've left the reporters on, we can see that the X position continues to get more and more negative. The Y position continues to get more and more positive. That sprite's direction is the same. So I'm going to hit stop. And I'm going to say, you know what? We need to come back to 0, 0. And we need to make sure if ever we hit an edge, I don't want to go past the edge. I'd like to bounce. So rather than make us do, there's a little bit of trigonometry you have to manage if you are approaching a barrier at a particular angle. I think it's angle of incidence and angle of reflection, if I'm remembering Physics 121 at UW from 20 years ago correctly. You can just say, you know what, do the physics for me. If you hit an edge, I want you to go ahead and bounce. So we click like this, and look at that. It gives us nice, clean-looking physics right there. And you can do all kinds of fun stuff with this. We'll end on a fun note. So you might say, you know what, put the pen down. And then, you know, how about let's change the pen size. How about set pen? Where is it? I know it's in here. Set pen size to 7. So it draws a big line. Now, how about we set pen color to red? Nice bright red. Oops, that's a pink. Sure, why not pink? And then what we can do is we can say change pen hue by 3. Every time it moves, change that pen hue. And now we get a rainbow. And if I change this to 10, now we can create an even cooler rainbow image. And what you see right here is not the product of all the blocks on the screen. It's just this little script I put together right here, which says, you know, move, change your color, and check. If you hit the edge, you need to bounce. So that was predominantly blue blocks, a little bit of pen blocks, a little bit of control blocks. But those are the dark blue blocks to help you make the very best snap programs you can. Hey, thanks for watching.